this isn't awkward at all. Da, da, da. I have water now. This is great. All right. All right. Hi. Let's talk about JavaScript. In JavaScript, what is 4 plus 2? 6. What is 4 minus 2? 2. What is 4 minus the string 2? 2. So of course 4 plus the string 2 is going to be 42. Okay. What is the truthiness of 1 double equals string 1? Hands up for true, hands up for false. It's true. But of course if we use actually equals, it's going to be false. Okay. Emoji. Who doesn't like emoji? If we try to split the string gem koala, we get an array of L. What is the concatenation of 2 empty lists? It's an empty string. What is the concatenation of a list and an empty object? It's the string object. Okay, that's weird. What about if we flip that around? What is the concatenation of an object and a string and an empty list? It's 0. What is the concatenation of 2 empty objects? Well, it's not a number. WAT. Who recognizes this WAT talk? This is a talk by Gary Bernhardt. You really should watch it. It's amazing. This isn't that talk. This is a why talk. I'm going to go through all those previous examples and explain why it's the way that it is. So let's talk about JavaScript. In this particular example, what we have here is an issue of implicit coercion. So what's happening here is JavaScript recognizes that it's a number and we want to negate something, and that string happens to end up being a number, so it works that out for us automatically. And in the second example, it's an overloaded operand. So instead of plus here, it's going, oh, one of those is a string, I'm going to concatenate. In this example, this is one of many examples in JavaScript of backwards compatibility having to be a thing. The first one, double equals, is equality with type coercion. So it's assuming that you know what you're doing in your types. If you wanted them to match, they match, but if not, that's okay, we'll match them for you. The triple equals came later because actually doing actual equality is actually important, actually. And in this particular example, this one's really fun. JavaScript predates Unicode, and it was about the same time that JavaScript was going along where UTF-8 was starting to be defined. So JavaScript makes assumptions about variable length encodings, and so gets it wrong. For this particular example, you want to be using array from, and it'll split up your emoji properly. For most emoji, caveats. Talk to me in the hallway after about wonderful emoji. That was my talk last year. This year's about JavaScript. In this particular example, this is a little bit more complicated. So being a completely, absolutely technical talk, I'm going to talk to you about plus. This is going to be complicated. So let's go to the spec. The ECMAScript 2017 language specification, 8th edition from June 2017. It says ECMAScript there. ECMAScript is JavaScript. JavaScript was a marketing name because Java was cool back in the day, but technically it's ECMAScript with its own defined standard, but I'm just going to call it JavaScript because it's easier to say. So section 12.8.3, the addition operator. What happens is, 2 sides of an equation, you convert them both to their primitive. To convert to a primitive being undefined, null, boolean, number, or string. Try value of. If that doesn't work, just cast it to a string, and that'll always return a string, and so you have your primitive. Then, is either side of the plus a string? If it is, turn them both to a string and concatenate. If it's not, convert them both to a number and then add them. So, for our examples, we had an empty list and an empty object, so we need to find out the primitives of an empty list and an empty object. For list, we try value of. It's the same, because a value of an empty list is an empty list, so it's not a primitive. So we cast it to a string, and it's an empty string. And if you're familiar with programming concepts, you'll know that in a bunch of cases, strings are actually just an array of characters that they just ignore the commas, so it actually reads like a word. So, object. The value of an object is an object. Yay! That makes sense. But if you send a object to a string, you end up getting a object. Now, this is a little bit confusing, but there's an absolutely good reason for it. Objects, when you cast them to a string, display their type. A lot of newer programming languages nowadays instead make a really nice stringy representation of what's going on. But JavaScript has backwards compatibility issues where you cannot have any legacy stuff because everything needs to always work. Always. The Space Jam website, yeah? That still works. That kind of thing. There is no versions in JavaScript. You can't tell your browser what version you want to use. So code and standards that were defined back in 1995 have to still be valid today. So they added a new function where you can find the stringiness of an object. So if you want to be using stringy stuff, use json.stringify because stringify is totally a valid word. Stringify. Okay, so we have our two primitives, so we can go back through our examples and we can substitute in and work out what our results are going to be. So, a list and a list, they're both strings, concatenate two empty strings together, you get an empty string. List and an object, you concatenate an empty list and the object string, and you get an object. Other way round though, that is assumed to be an empty code block, which is a no operation, so we're going to ignore it. Code block. Which means that the rest of the function is going to be a unary addition, which means we're pretty much just going to cast that to a number and it's going to be 0. So we end up with 0. And then if we do two empty objects, the first one is a code block, but the second one is cast of an empty object. And we know that an object is actually a string, so when we try to do a numeric casting of a string, it's an error. And so we get the error. Ta-da! It's a shooting star. See, I told you I liked emoji. But let's talk about JavaScript as of Chrome 64. Chrome 64! The top two examples are exactly the same, except now if you're using the Chrome 64 inspector, this is no longer assumed to be a code block. It is assumed to be an empty object, which means that we're concatenating object, object, and empty string, which means we get the same result if they're flipped. And this second one is the same again, two strings, so you get object, 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 which means that now these two operations, even if you flip which side of the plus the operands are on, they're the same. Which is awesome, because it's now commutative. Same forwards as backwards. Woo! So, JavaScript isn't awful. JavaScript is awful. It's full of awe. It's a 22-year-old programming language that has to be 100% backwards compatible. And if you don't understand the design considerations around this, you might think that these are WATs or edge cases or bugs. But this is how JavaScript is designed. But that's okay. If you don't like JavaScript, if you think it's weird or whatever, just don't use it. There are so many other languages you can use in the browser, like JavaScript. You could have used Flash and ActiveX during the day, back in the day, but thank goodness we don't have to use them now because security is a thing. But that's okay because there are a whole bunch of other languages that you can use and then compile them down to JavaScript. There's a couple of hundred examples in there. One of them up there is Batavia, which I helped write. I have stickers. Come see me afterwards. But using another language won't save you. Let's talk about Ruby. In Ruby, what is the truthiness of not true, double, and false? Hands up for true. Hands up for false. It's true. What is the truthiness of not true and false? Hands up for true. Hands up for false. It's false. Yeah, you want to know why? Praise precedence. There is a order that operations happen in Ruby, and right between double and, there is a not, which means that that not means that that's where the implied brackets are in this equation. Double and are not equal, people. It's really fun when you find this in your code, by the way. But enough about Ruby. Let's talk about Python. In Python, if I declare a variable a as 256 and a variable b as 256, is a b? True? False? It's true. If I declare a variable a as 257 and b as 257, is a b? True? False? It's false. But if I declare both variables on the same line and check, they are. Let's talk about Python. When you run Python, you're probably running CPython. When CPython starts up, it gives you a lovely cache of integers. The cache stops at 256. When you assign a variable that's within this cache, it will point to the existing cache. When you do it again, if it's within the cache, it'll point to the existing cache. And this is object identity, not equality. So it sees those as the same object, and it's fine. But if I was to extend this out beyond the cache, the value of that variable is stored outside of the original cache. And then on the next line, it stores it outside of the original cache. And so they're not the same object. But if I declare them on the same line, I can have the compiler optimize this for me, and it sees that they're both the same and stores them in the same place, so they are the same object. CPython does a whole lot of these optimizations under the hood, and it makes your code a whole lot faster. But if you're using this kind of thing, make sure that you're not using object identity as a equality operand. Actually use equality. So then you'll make sure that it's actually checking the values of the objects, not the pointers of the objects. Let's talk about Java. In Java, if I declare a variable a as 128 and a variable b as 128, is a less than or equal to b? True? False? It's true. Come on. There are no trick questions here. Is a greater than or equal to b? True? False? True. So a must be b, right? That is an error in my slides. I'm so sorry. That is supposed to be false. I'm sorry. I've got like 8 more code examples to go. Most of the other code should be fine. That is identity, not equality in Java. So the integer cache in Java goes from -128 to +127. They're not in the cache, so it's the same thing as in Python. So you should be using equals. Yeah? Okay. Or, in Java, you shouldn't be using integer, you could use int, the primitive integer type. Integer has all these fancy functions and stuff around it. Int is basic, so you can use mathematical equality under the, out of the box and it'll just work. Let's hope I don't have any more errors like that. Anyway, all languages, when you first see these things for the first time, you may think that it's a quirk, it's a bug, it's something that obviously has to be an error, right? But if you have a deep understanding of how the language works, it's not a quirk, it's how the language works. Let's talk about Perl. In Perl, if I want to check whether the string A is equal to the string B, it'll print out true if it's true, otherwise it'll print out false. So, hands up for true, hands up for false. Double equals in Perl is numeric equality. It will cast both of these strings to a number and then check them. You should be using EQ for string equality, in Perl at least. So this is how many different languages now where double equals acts in different ways. Don't ever assume your operations are going to just work when you cross language barriers. Let's talk about Bash. In Bash, what is 4 plus 2? This is because by default, Bash doesn't understand arithmetic. You have to tell it to try to parse what it's given. So if I wrap it around in a couple of brackets and another $, what is 4 plus 2? No, it's not. Because Bash is a shell, and it doesn't know how to print out 6 until you tell it to echo out the result for you. This is by design. Bash is not an arithmetic machine. It is a shell. You run commands. You don't do math in Bash. You can, but you need to know how to do math in Bash properly. Let's talk about Haskell. In Haskell, if I declare a variable a as 2 plus 2, what is a? 4. There are no trick questions here. Every example that I'm giving has a purpose, and there's a reason behind the madness. In Haskell, if I have a variable a as 2 plus 2, where 2 plus 2 equals 5, what is a? 5. This is completely valid Haskell. This is pattern matching. This is a wonderful thing that you can do in Haskell, where you can define a function and tell it exactly what to give you back depending on what your variables are. So this would be Fibonacci, where I have, if I put in 0, it's 0, 1 is 1, otherwise do a recursive. And this is exactly the same as what you would get in Ruby, where you exit early, except the Haskell one looks kind of pretty. Let's talk about Elixir. In Elixir, if I have a range of 1 to 5, and for that range, I want to find the square of the number, and then I map over that, so I go 1, 2, 3, 4, 5. I will get 1, 4, 9, 16, 25. Yeah? Yeah. So what happens when I go from 6 to 10? Who knows the history of Elixir? Great, let me tell you. Well, the one person that knows. For everyone else, Elixir is kind of cool. This was apparently supposed to be ElixirConf? No? Yeah? Okay. Elixir is built on top of Erlang. Erlang is old. Like, proper old. Like, strings are represented as a list of characters old, which means that if I was to do this properly, instead of assuming that Elixir knows what I want to print out, I am going to tell it explicitly for every item in my array, print it, and I get the right result. Because Elixir is assuming that I have a string when I have an array of single numbers, and numbers equate to characters. How can I prove that? By changing my range from 6 to 10 to 65 to 90. And I get the alphabet. This is absolutely by design. You shouldn't be using your Elixir interpreter to assume you know how you want to represent your data. You should be using I/O. Cool. Let's talk about Scala. In Scala, if I print out the result of the concatenation of an empty object and an empty string, what do I get? This is an empty result in the Scala interpreter. This is completely valid. This is by design. This is the empty output representation. That's fine. It just really trips you up when you start playing with Scala and wondering where all these brackets and braces and what happened to your lovely strings. Not that I've ever had that happen to me before, no sir. No language is better than any other language. The mere fact that a programming language exists means that it's many hours, weeks, months, years of work by many people building a common dialect to describe and manipulate data in the realm in which they reside. Each language has their own strengths. Let's talk about PHP. In PHP, there are ternary operators, which means that depending on the truthiness before the question mark, we either execute the left or the right side of the colon. So in this example, it'll print true, and in this example, it'll print false. That's fine. We can also chain together these ternary operations. So if I have false, 1, false, 2, 3. Hands up if you think it will print 1. Hands up for 2. Hands up for 3. 3. If I change it to false 1, true 2 or 3, hands up for 1, hands up for 2, hands up for 3. 2. If I change it again to true 1, true 2, 3, hands up for 1, hands up for 2, hands up for 3. This is completely valid PHP because in PHP, ternary operators are left associative, which means that when we have a series of these chained together, this is what's being implied by the brackets. It's checking whether the top one is true and then continuing. You should really not be chaining ternary expressions in PHP, but that's how the language works. And if you understand that, it's not a WAT, it's how the language works. Let's talk about PowerShell. In PowerShell, if I want to check if 2 is greater than 1, if it is, print true, else print false. Hands up if you think this will print true. Hands up if you think this will print false. It's true. 2 is greater than 1. There are no trick questions here. If I did this the other way around, check if 2 is less than 1. Hands up for true. Hands up for false. I'm still not 100% sure why this is the case. If anyone knows, please tell me. I'm sure there's a completely valid reason, but that is normally what you would see in Bash's input redirection. The problem is that somebody thought it was a good idea to implement one of them as a numeric comparator but not the other. You should be avoiding these entirely and using the actual comparison operators of -gt, -lt. It also means that you don't have to remember which way the crocodile goes because you know one is less than and one is greater than. I've just gone through nearly a dozen programming languages and shown what could be described in each as a WAT. But if you have a deep understanding of how the language works, it's not a WAT, it's how the language works. So whenever you find yourself thinking WAT, turn it into why. Find the reasoning behind why this is a thing. Understand the decision process from the implementers of the language of choice as to why this is a thing. It will help you get a deeper mastery of your language, and you just might learn a thing or two across the way, because these are all examples that I've come across. I am a polyglot developer. I've been doing this for years now in every one of these languages, and I used to think that just because I was a Ruby dev, Python are terrible, or I'm doing Haskell now, everything that's not functional sucks. But they're tools. They're tools to manipulate data, to solve problems, to provide solutions, and each of them has their place. And it's like how if you only understand English, but you start learning, say, French or Japanese, you then have 2 completely different languages in which to communicate yourself, and you'll find things that English doesn't provide, or that French does better, or that English does better. And you can be an absolute goddess of emoji, of Ruby, and that's fine. If you only know Ruby and you know Ruby well, that's great. But why not try your hand at something else? You might learn something more about Ruby and how it works along the way. Unrelatedly, I'm running the Python conference just down the road in a couple of months if you want to come along. But that's all I had. Thank you for your time.